welcome to our video on interest. So in this video, we are going to learn how to um, use simple interest formula to solve problems, use compound interest value to find future value, and hopefully through these two skills, you will also be able to solve the compound interest formula for unknowns. Although we're not going to spend a lot of time working on that third objective. So first of all, what is interest? Well, interest is the amount of money that we pay when we borrow money. It can also be the amount of money that is paid to us for investments, such as a savings account or some other interest-bearing account. So the interest earned, I, is equal to the principal, which is the initial amount, so the amount you deposit or the amount you borrow, times the interest rate, R, and this is the interest rate percentage written as a decimal, that percentage converted to a decimal, and then times time. And time is the amount of time, typically in years, that is allotted for the investment or purchase. All right, so let's solve this problem for the interest, okay? And this is just simple interest. So we are going to use our simple interest formula. I is equal to principal times rate times time. And in this case, our principal is 1,000. Our rate is 8% and written as a decimal 0.08. And then our time is 3 years. And so you are going to grab your calculator and multiply these three items together. So 1,000 times 0.08 times 3 for the number of years. And this tells us the amount of interest is going to be $240. Okay, so if we're talking about a $1,000 loan, we would pay back $240 in interest. If we're talking about a $1,000 investment, we would gain $240 in interest. So finding the future value using simple interest. Well, future value is just the initial thing. So from our previous example, we had the $1,000, and let's say that we invested it. We earned $240 in interest. So we add those two things together, and that is how much our investment is worth at the end of our time period of 3 years. So it's the principal plus the interest, or the principal plus, remember our interest formula is principal times rate times time. And when we algebraically factor out our common factor of those things, we find that the formula is future value is equal to principal times 1 plus the rate times time. And that all condenses into this formula. A is equal to P times 1 plus RT. So you can see from this graphic how that formula is derived. So if you don't remember the formula, that's okay, because just remember that future value is nothing more than principal plus the interest. And remember your interest formula. I is equal to P times R times T. So it's the principal plus principal times rate times time. If you are able to memorize the A equals P times 1 plus RT formula, great. But if not, future value, again, it's nothing more than principal plus the interest earned. All right, so let's calculate our future value. Well, remember that future value is our present value or principal plus our interest. Okay? Ooh, gotta spell there. So I'm going to do this the long way. Okay, so we know that our principal is 2,500. And then interest, remember this guy here, PRT, right? So principal times times the rate times the time. Okay. So we know that our interest, 2,500 times 0.08 times 3 is 600. So this ends up being 2,500 plus 600, or 3,100. Okay, so that's doing it the quote long way. If we use the formula, okay, then we have 2,500 times 1 plus 0.08 times 3, okay? And we put that whole thing into our calculator, and it's still going to give us $3,100. So either way you remember how to do this, it still gets us to the same solution. Compound interest. Compound interest is called compound because you are building on the previous balance. So if we are compounding, let's say that we're just compounding yearly, then you start with your initial investment and you get interest for that year. But in order to calculate the interest for the second year, we have to go on our new balance, which would be the principal plus the interest earned. So let's look at how that looks, kind of like doing it the long way. Okay. So in year one, okay, in year one, the balance at the beginning of the year is $5,000. Okay. The future value, remember, we're going to have, it's going to be the principal plus the interest. Okay. So for the first year, it's going to be 5,000 plus 5,000 times 0.05. Okay. So at the end of the first year, the balance is $5,250. Okay. So year two, well, our beginning balance is that 5,250. Now, in order to find our future value, we take the 5,250, but now the interest that we add to it is the interest on the 5,250. Okay. And that gives us a balance of $5,512 and 50 cents. So for year 3, okay, so if you've noticed the pattern, so now we're going to take the 55, 12.5 and add the interest. Okay. And when we do that, that gives us a balance now of $5,788.13. So each year, when we add the interest, this is why it's called compounding, because we are building off of the previous year's balance. Okay. So we continue here. Year 4. We now have $5,788.13. And again, we're going to take that $5,788.13 and add the interest for $5,788.13, which now gives us a balance of $6,077.54. So at the beginning of year 5, we have in the bank account $6,077.54. This is now the new balance that we're going to use to calculate the interest. So we need to add the interest that is calculated for $6,077.54. And we now have in the account $6,381.42. So that's how we compound. We add on top of the year previous. And this is the long way of doing it. It really doesn't it can be done this way, but yeah, it's a very, very long way of calculating compound interest. We do have a formula, though, that can make it a little bit easier. So here is our compound interest formula, okay? And when we are using our compound interest formula, all right, we still are looking for our future value there. Okay, P is still our principal, R is still our interest rate. So that still all works. M, however, is the number of compounding periods in a year. Okay, and T is the number of years. So we need to understand what it means by the number of compounding periods in a year. So if our loan or our investment says that the interest compounds yearly, that's only compounding one time per year. Biannually is twice per year. Monthly would be 12 because there's 12 months in a year. Weekly would be 52, again, because there's 52 weeks in a year. And daily would be 365 because that is the number of days in a year. So we have our compound interest formula as future value is equal to the principal times 1 plus the rate divided by the number of compounding periods. And that sum, it is important to note that the sum of 1 plus R over M is the only thing that is raised to the MT power. A lot of letters, a lot of words. Let's look at what it means and what it looks like in actual practice. I think that would be really helpful. Okay, so previously we had gone the long way to find the future value of this investment at 5% interest compounded yearly after 5 years. So our future value is equal to the principal times 1 plus our rate divided by the number of compounding periods raised to the MT power. Okay, so our principal is 5,000. 1 plus our rate, 0.05. Our number of compounding, because it's yearly, is 1. And this is going to be raised to the 1 times 5 power. Okay. So we could go ahead and just put this whole thing into our calculator right away. But I'm going to just kind of walk it through a little bit, because 0.05 divided by 1 is just 0.05, and 1 times 5 is just 5. And this ends up being 1.05. Now, what is important here is that this right here is the only piece that is raised to the exponent, okay? So 1.05 raised to the 5 power. That gives us 5,000 times 1.7, I'm sorry, 27,628. I'm going to just round it off there. And when we take that and multiply it by the 5,000, we get an amount of $6,381.41, which is exactly, well, we got 42 cents when we went the long way. And that's because the difference in the penny there is because we rounded off each time to the nearest penny on the one previous, doing it the long way. And using the formula here, we were able to jump right to the dollar amount. So that's pretty close, though, when we do it the long way of getting it to 42 cents, and our actual answer is to 41 cents. So that is how we use that formula. All right, now let's talk about something a little bit more practical. And I wanted to kind of throw this one in because this is something that a lot of you are going to face. So, and this is where it comes, it's really important to understand interest and interest rates, because it can really kind of come back to bite you in the long run. Okay. So let's say that you want to buy a new car. And you go in, and the first thing that the salesperson asks you is, where do you want your car payment to be? And you tell him that your budget is no more than $500 a month for your car payment. And you say, I've got $3,000 to put down. And the salespeople say, okay, wonderful. And we're going to give you $3,000 for your trade. And the car that you're looking at is $25,500. That's going to be the total price of the car. That's tax, tag, title, all the fees and everything. And you think, you know what? That's wonderful. And they got my monthly payment at $499 for 6 years. Well, that's great, right? I mean, the payment is less than what you want. Um, everything looks great. Well, let's take a look here. Okay. So the price of the car, $25,500. You subtract your trade and subtract your down payment. Okay. So 25,500 minus 3,000 minus 3,000. Okay. Gives you 19,500. Well, that's wonderful. Okay. You're getting a really great deal on this car. It looks like, and you're going to be making these $499 payments for 6 years. Well, actually, wait. You're going to be making that for 12 months out of the year for 6 years. So at the end of this, when you've made all of your payments, you will have paid a total of $35,928 for your $19,500 investment. Which means when you take a look at this, that means that you have paid $16,428 in interest. So let that sink in. This is why it's important when you are a consumer of goods, whether it is a new car, an investment, a home, we need to be looking at all of the numbers. And we also need to understand exactly what interest is and how it is calculated. Because you are paying nearly twice what that car is worth at the end of all of this. And speaking of cars, if you know anything about them, the depreciation, you have almost $36,000 invested in a vehicle that is probably after 6 years only going to be worth about $8,000 to $10,000 depending on the car. So think about that while you are deciding how to be a wise consumer when it comes to interest. And please reach out with any questions you have.